Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an Associate Professor in the Department of Electrical and Electronics Engineering. So in today's class, we are going to discuss numerical problems on the nodal analysis. So we have already discussed about the nodal analysis. So how we can apply the nodal analysis to solve the voltage across the nodes or to find the voltage at a particular node. So in this today's class, we are going to take the various numerical problems, and which means various circuits we will consider, and the circuits also having the dependent sources. And also in this today's class, we are also going to discuss the concept called the super node analysis. So which means when we should apply the super node analysis, then how to apply the super node analysis to find the voltage at a particular node. So first of all, let us go with a simple electrical circuit. So here for this electrical circuit, we need to find the voltages of V1 and V2. So here the voltages of V1 and V2, here it is V1 and here it is V2. So already the nodes they have given in the given problem. Okay, so that's why we no need to again indicate the V1 and V2. That's why I told you just it is a simple network. So for this simple network, first we need to write the node equations. So before going to that, here the node equations are nothing but here we should apply the KCL at these particular nodes. So as we know, what is meant by the KCL, which is Kirchhoff's current law. So according to the Kirchhoff's current law, the sum of the currents entering towards the node, which is equal to the sum of the currents leaving from the node, right? So the sum of the currents entering to the node, which is equal to the sum of currents leaving from the node. So first let us consider here the node which is called as a V1. So at V1, first we are going to write the voltage equations, right? So then as the current equations actually, because as we know, I is equal to V by R. So here we are considering the voltage at this particular node is equal to V1. Okay, so that's why then V1 by 10 and V1 by 5 and something like that, we are going to write here the nodal equations, right? So first here, let us consider here the current flowing through this particular branch. Here it is already indicated, this is 6 amperes. And let us consider here the current flowing through this particular branch is also, let us consider in this direction. Okay, and the current flowing through this particular branch is, let us consider here this way, and here it is this way, right? Then here the sum of the currents, okay, entering towards the node, which is equal to sum of the currents leaving from the node. Then what are the currents entering or the leaving from the node? Okay, well, let us consider here it is V1 by R. Okay, right. So here then V1, all are the what is that, the currents leaving from the node. So that's why here then I'm just writing V1, because this particular node, let us consider here it is I1 and I2, and this is I3 and this is I4. Let us consider for our simple understanding, right? Then according to this the KCL, so all are the leaving currents from that particular node. So that's why we can write it as I1 plus I2 plus I3 plus I4, which is equal to 0, right? So here what is I1? I1 is the current flowing through this 10 ohms resistor. So then the current flowing through 10 ohms resistor is I is equal to V by R. So here the V is V1 and R is 10. So let us consider here it is V1 by 10 plus, and I2 is the current flowing through the 5 ohms resistor. So V1 by 5 plus, here I3 is already they have given the current. So directly I am writing 6 amperes because the current source, plus here I4 V1 minus V2, V1 minus V2, because the potential difference across this resistor is V1 minus V2. Okay, by here 2 is equal to 0. So let us consider this is equation number 1. Then next we should write the equation number 2 at this particular node. Okay, so here as you can see here the current okay, let us consider here the current flowing through. Here it is again this direction, and here they have already given, so this direction, and this is, let us consider in this direction, and this is also they have already given, right? Then here the equation will be, here this is entering, okay, and this is leaving, and this is leaving. So that's why let us consider first entering current. So entering current is here 6 amperes and 3 amperes. So 6 plus 3, which is equal, and the leaving currents, each is flowing through the 2 ohms and flowing through the 4 ohms. So here it is V2 minus V1 by 2 ohms plus here V2 by 4. Let us consider this is equation number 2. So by solving this equation number 1 and 2, by solving 1 and 2, then we can find the values of V1 and V2. We can find the values of V1 and V2. So by solving these two equations, then we will get the value of V1, which is equal to, here we are getting 0 volts, and the value of V2, which is equal to, here we are getting the 12 volts. So this is how we can apply the nodal analysis. This is a very simple circuit, right? Next, we are going to solve the next problem. Yeah, this one. So here this is the given problem, and in this given problem they are asking us to find what is the current flowing through I1 and I4, which means here we need to find I1 and I4. These two values we need to find. So by applying the nodal analysis, right? So then first of all we should identify how many nodes are there for this particular circuit, right? So here as you can see, this point, and this point, these all are connecting at the same point, because in between these 3 points there is no other element. Okay, so which means here let us consider here this is node 1. Okay, and another node here, it is this one and this one also having the same. So that's why here this is node 2. Okay, and another one is this is node 3. So we usually, as we know in the nodal analysis, okay, so usually n minus 1 nodes we usually take, okay, because the another node is, we usually take it as a reference, and that particular reference node we usually take the potential as 0. Then here the first node, let us consider here it is V1, and the second node here it is, let us consider V2. So the potential at node 1 is V1 and the potential at node 2 is V2, right? So the same way here they have written like this. You can see here it is V1 and here it is V2. Now if you know the V1 and V2 values, then it is easy to find the current I4 and I1. What is that? I1 value, because I1 is equal to V1 by 20, then you will get I1, and I1 is equal to here V1 by 20, then here I2 is equal to here I4 that they have asked us to find. I4 is equal to here V2 by 40. So if you know the V1 value and V2 value, then it is easy to find the I1 and I4 values, right? Then further here again we are just writing the nodal equations for this particular circuits. So already here they have given the current directions in each branch. Okay, so we no need to again represent the current branches, right? So then here this is one, right? So at this particular case we are applying the nodal analysis. So through this branch they have already given, but it is in opposite direction. So first let us write the currents entering towards the node. So the current entering towards the node is here 6 amperes and 3 amperes. So that's why here 6 plus 3, which is equal, and the leaving currents are here these I1 and I2. Okay, so here I1 is V1, actually V1 minus 0, because here it is the 0 potential, so that's why I'm not writing, but for our understanding purpose just let me write. So V1 by V1 minus 0 by this 20 plus here again V1 minus 0 by this 10. Okay, so let us consider this is equation number 1. Okay, so then okay, all are V1s only, then we can simply simplify this, so that if you simplify this you will get here V1, which is equal to 60 volts. So this is, let us consider, this is equation number 1. Then now we are going to apply the nodal analysis at this particular node V2. So then here again, what are the living currents? Here these 3 are the living and 1 is entering current. So first let us write the living currents equations. So here 3 plus and V2 minus 0, V2 minus 0 by 40 plus here V2 minus 0 by 40 again, because here the 240 ohms resistors is there. Okay, and Yeah, and then entering current here it is 2 amperes. So then 2. Then if you simplify this, then you will get finally the value of the V2, which is equal to minus 20 volts. So here V1 is equal to 60 and V2 is equal to minus 20 volts. Then here what we need to find the value of I1. So I1 is equal to V1 by 20. So here V1 is 60 by 20. Okay. Then you will get the I1 value. So I1 is equal to 30. So 30 amperes I1 is. Then similarly, you can find the value of I2. So I2 is equal to V1 by 10. So here V1 is again 60 by 10. Then you will get 6 ohms. Okay. So here it is 3. Then you will get here it is 6 amperes. Then coming to I3. So I3 here it is equal to V2. So V2 here it is minus 20 by 40. Okay. So V2 is I3 is equal to here minus 20. V2 value is minus 20. Yeah, minus 20 by 40. Okay. This is I3. Right. So which means here minus 1 by 2. So which is equal to 0.5 amperes. Then similarly I4, which is also same. Okay. So minus 20 by 40. Okay. So which is equal to minus 1 by 2 and which is 0.5 amperes again. Minus 0.5 amperes. Okay. So here minus represents because actually the current direction I3 and I4 is indicated in the problem is like this. So here minus 0.5 means actually the current direction is opposite to this because here it is this one and here it is this way. This is the flow of the current direction, right? So that is what here the negative sign indicates. Okay. So this is the way to apply the nodal analysis, and by applying the nodal analysis, we can find the potential at a particular node, and by finding the potential at a particular node, then we can also find the current flowing through that particular branch. Next, we are going to what is that? Solve the next problem, the problem 3. So here again we need to find the voltage V1, okay, which means what is the voltage across this 10 ohms resistor that they are asking us to find. So then how to find this voltage across this 10 ohms resistor? So here it is very simple because again here we need to just identify the node. So here we are having only one node. So let us consider here uh, this is V1, okay. The potential here it is V1 because here are here both are same. Okay, the potential is V1 because anyway here the potential we are making it as a the ground, so 0. Then if you write the equations for these, so first of all then V1 minus 0, okay, not 0 actually, here 10 is there. So V1 minus 10, first equation V1 minus 10 by 10 ohms plus again V1 because V1 minus 10 again by 5 is also there because one is the current will flow through this way, okay, another one is the current flow through this way. So that's why here again V1 minus 10 by these 5 ohms, okay, and plus here this is V minus 0 or V1 minus 0 by 10 ohms plus here V1 minus 20 by 4 ohms, which is equal to 0. Then if you simplify this equation, then you will get the finally, so here 0.2 plus 0.1 plus 0.1 plus 0.25, okay, into V1, which is equal to 2 plus 1 plus 5, okay. Then finally here the V1 value that you will get, which is equal to 12.308 volts. Right. So then here this is the V1. So here V1 is nothing but the voltage across 10 ohms resistor. Okay, so this 10 ohms resistor. So you can also find, I mean, yeah, because already we know what is the voltage across other things. Okay, so that's why here the voltage across the 10 ohms, which is V1. So V1 is equal to here 12.308 volts. So this is how we can apply the nodal analysis, right? Then let us go for the another problem. So in this problem, we are, I mean, the this network consisting of the dependent source. So this is the dependent source. So then in this case, how to apply the nodal analysis, right? So here also almost more or less the same procedure that we are going to apply, okay? Because here, but here the V naught, we don't have this voltage value because it is an independent, it is a dependent voltage. So the voltage, the value of this voltage source is depends on the voltage across this 4 ohms resistor, okay? So that's why here this voltage value, the voltage source value is 5 into V naught, okay? Then here the same way, first we need to identify the number of nodes. So of course here, here it is having this node. Let us consider the node is V1. Then let us indicate the current directions. Okay, so here it is I1 current direction, and here it is I2 current direction, and here it is I3 current direction, right? So then according to the what is that KCL, okay, so the sum of the algebraic sum of the currents at a particular node is equal to 0. So that's why here I1 plus I2 plus I3, which is equal to 0. Then substitute the value of I1, I2 and I3. So I1, I is nothing but V by R. So in the first case here it is V1, okay. So V1 minus 0 by 4. So in the first case here it is V1 minus 0 by 4. So the same equation here I am writing. So here V1 minus 0 by here 6 and 4 both are connected in series. So that's why here when I1 is equal to here V1 by 6 plus 4, 10 plus, then coming to the I2. So I2 here it is V1 minus 60, V1 minus 60 by 20, right? Then coming to the third one, and third one is V1 minus here 5 V naught. The voltage is 5 V naught. So V1 minus 5 into V naught by 20, which is equal to 0, right? But here, as we know, this V naught value. So here V naught, which is equal to, what is the value of the V naught? Here it is V naught, which means the voltage across these 4 ohms resistor, which is V1 by R. Let us consider, okay. First of all, what is I here? So here I1, which is equal to V1 by 10. Then the voltage across this 4 ohms resistor, here it is V naught, which is equal to 4 into I1, right? So here 4 into I1, what is I1? Here it is V1 by 10, okay. Then here 2 2s and 2 5s, okay. Then V naught is equal to here 2 by 5, right? So if you substitute, 2 by 5 into V1, okay. If you substitute the V naught value here, okay, then you can find the value of V1, okay. You can find the value of V1. Then substitute the value of what is that? This V naught. Then if you substitute the value of V naught here, then you will get the finally, or if you simplify this, then you will get here it is 2V1 plus V1 minus 60 and plus V1 minus 2V1, which is equal to 0. Because here I have just substituted here V naught is equal to here 2 by 5 into V1, right? Then if you simplify this, then you will get finally here V1 is equal to 60 by 2, which is equal to 30 volts. V1 is equal to 30 volts. So according to our given problem, what they are asking us to find the V naught value. Okay. So here V naught is equal to 2 by 5 into V1. So here 2 by 5 into here V1 is 30. Okay. So 5 6. So then here it is 18 volts. V naught is equal to 12 volts. 6 into 2, 12. So here finally the V naught is equal to 12 volts. This is the answer. So see how simple it is, right? So because here the dependent source value is 5 into V naught, and here V naught is the voltage across the 4 ohms resistor. So as we know here V naught is equal to 4 into I1, because I1 is the current flowing through this 4 ohms resistor. So here I1 is equal to V1 by 10. So then substitute here, then you will get the value of V naught in terms of V1, which is equal to 2 by 5 into V1. Then after that substitute these V naught value in this equation number 1. Then you will get the value of V1, which is equal to 30 volts. And after getting the value of V1, you can just substitute here. Okay, then you will get V naught is equal to 12 volts. Let us find another problem. So here this is here we are going to apply the super node analysis. Okay, so super node analysis. I mean, when how do you know that here we need to apply the super node analysis means, because here in the given problem already they have given the three nodes V1, V2 and V3. But here if you observe, in between V1 and V2 there is a voltage source. So if there is a voltage source in between the two nodes, then here we should apply the supernode analysis. Which means in the supernode analysis, we usually consider these two nodes as a single node and we will write the equation. So because this is node 1 and node 2, node 3, okay, or node 1, and this total is a supernode and this is the node 2 second node. Okay, then by applying these two, the current equations at these two nodes, then we will be having as a super node, which means here by combining this V1 and V2, we are making it as a super node. So like this, here it is as a super node. Then write the voltage equation or the KVL or the KCL for at the particular this super node equation. Then that will be the equation number 1. So here you can see, I mean, how we are going to apply the how we are going to write the equation, right? So here in the first case, anyway, this is entering current for this particular, I mean, in this combination of this super node. So here it is 2 entering current 2, which is equal to, and here it is V1 by 1, okay. Because here it is in terms of S, so that's why we are, instead of writing by 1, here we are making it because inverse, so that's why we are writing it into. So here V1 into 1 plus, and another one is here another V1 minus V3. So V1 minus V3 into 2, because here it is there 2 plus, and another one here, yeah, and V2 minus V3 into 8. So V2 minus V3 into 8. Then another one, yeah, V2 minus 0 into 4. And here I am writing. So yeah, and V2 minus 0 means here 4 into V2. Okay, so this is the equation number 1, and by simplifying this, then you will get here 2 is equal to here 3V1 plus 12V2 minus 10V3, which is equal to equation number 1. This is at what is that, the first node equation, right? But here, as you can see, this V1, which is equal to V2 plus 2 into V0. Okay, V2 plus 2 into V0. So because here this is V1, okay, so V1 is equal to V2, okay, plus here because 2 into V0. So then, because here as you can see, why here it is, because here V2 which is equal to V0, because here V0 is the voltage across the these 4 S resistor, okay, and so that here the V2 is equal to V0. So wherever the V2 is there, so at that particular case or at that particular place, you can substitute the value of what is that, V0. Okay, then if you substitute the value of V0, then hence here V1 is equal to 3V2, because here in the place of V0 you can just substitute the V2. Then V1 is equal to 3V2. This is another equation. Then another equation here V3 is there. So here V3 which is equal to, because here V3 which is equal to already directly 13 volts is there. So V3 is equal to, here it is 13 volts. So now we got one, there is one equation and second equation and third equation. Now you got the 3 equations, right? Okay, so how we got this equation means here, actually, I mean exactly this especially this equation. So at V2, okay, so V2 minus V1, okay, V2 minus V1, okay, so V2 minus V1 which is equal to V2 minus V1, which is equal to here 2 into V0, because in between 2 V0 is there, because from here, yeah, from here, so here V2 minus V1, so V2 minus V1 which is equal to 2 into V0. Okay, so from this here V1 is equal to not V1 minus V2, sorry, not V2 minus V1. Okay, so here it is V1 minus V2, because here plus and minus. So V1 minus V2 which is equal to 2 V0. So then here V2 is equal to what you got? V2 plus 2 V0. Yeah, V1 is equal to, not V2. So here V1 is equal to, if you send this one to the right hand side, then 2 V0 plus V2, right? So, but we know what is V0. Here V0 is nothing but the V2, because here already we have considered the potential is V2. So that's why here 2 into V2 plus V2 into V1. So here V1 is equal to 3 into V2, right? So this is what here V1 is equal to 3 into V2. That is how we got the value V1 is equal to 3 into V2. Then let us consider this is equation number 2 and equation number 3. And by solving equation 1, 2, 3, 1, 2 and 3, then we will get the value of V1 and V2 and V3 values, right? Then the V1 value here it is 18.85 that we got, and V2 value here it is 6.28, and V3 value here it is 13 volts. So according to the given problem, what they are asked us to find V1, V3. Okay, so here V1, which is 18.85 volts, and V3 is 13 volts. So this is how we can apply the super node analysis. Okay, so when there is a voltage source present, okay, in between the two nodes, in that case we will apply the super node analysis. So the super node is nothing but here by we are making the combination of those two nodes as a single node. Okay, then by using, I mean, in that way we will make that is as a super node, and we will write the whole equation for that particular super node. Same like in the super mesh analysis, that also we will discuss. So then next problem. So here we need to find the voltages V1, V2 and V3. So here already they have given. So here they have already given the node voltages indication, like here it is V1 and here it is V2 and here it is V3. So now we need to write the voltage equations at each node, or which means like that we need to apply the KCL, okay, at each node. Then for that we need to write the equations. Okay, so first let us consider the node 1. So for that V1, so already here the current direction they have given, okay, and let us consider here the current direction, this is also that they have given, so this way. So let us consider here also the current direction is this way, and here also let us consider the current direction is this way, and here also let us consider the current direction is this way. Okay, so in this case let us consider, okay, this is I1 and I2, I3, I4 and I5, right? So as we know, according to the KCL, okay, so which means KCL at V1. So what are the entering currents here? Only one entering current is there, which is 5 amperes. So 5 amperes, which is equal the leaving currents. Okay. So I2, which means V1 minus 0, because here the potential is 0 that we are considered. So V1 minus 0 by 4 plus, and here I3 is there next. Here V1 minus V2 by 8. V1 minus V2 by 8. Okay. Or before that, first let me write here this one. I1 is equal to I2 plus I3 plus I4 plus I5, right? So here I1 is 5 amperes, I1 is the 5 amperes, and here I2 is V1 minus 0 by 4 plus here I3 is V1 minus V2 by 8 plus, okay, then here I4. So I4 here it is V1 minus V3. So V1 minus V3 by 2, and plus here I5 is V1 minus, not V1 minus, okay, so here I5 directly they have given, so which is 3. Then if you simplify this equation, then you will get finally the value, okay, let us consider this is equation number 1. Then coming to the second, the voltage at node 2, okay. So here apply the KCL at node 2, okay. So in this case, let us just remove this. Then now we are going to indicate the currents here, okay, V2. So let us consider, of course, if you, I mean, we can consider both the ways, because already we have considered the current is in this direction, so we can make it same as it is like that. But if you consider the direction is something like this, then here with respect to V2 also, here V1 minus V2 by 8 the current. Okay, otherwise if you want to make it the current direction is this way, okay, then here the equation is V2 minus V1 by 8, both are same. Okay, so that's why there is no issue. So then otherwise indicate the same way here. Okay, so here it was before I3, okay, and here it is I4, and here it is I5, right? The same way you can make it. So then let us consider here it is I6 and here it is I7, right? Then and this one that we have considered, here it is I1 and here it is I2. So then at node V2, so what is the entering current? I3 which is equal to I6 plus I7, right? So here I3 which is V1 minus V2 by V2 by 8, which is equal to V2 minus V3 by 4 plus V2 minus 0 by 2. Let us consider this is equation number 2. Okay, now with 3, okay, so here 3, let us consider here this is the current I8. Okay, so then at V3, at node V3, then if you write the equation, so here V2 which means here I7 entering current, okay, and other entering currents plus I4 and plus I5 which is equal to I8. So here I7 is V2 minus V3 by 4 plus here I4 is V3 minus V1 by 2, okay, and plus here I5 which is, yes, 3 amperes which is equal to I8. So I8 here it is the current flowing through 8 ohms, then here V3 minus 12 by 8. So let us consider this is equation number 3. Then by solving 1, 2 and 3, then we can get the value of V1, V2 and V3. Okay, if we are having the 3 equations, then in this case we can make it like this. Okay, so first let me simplify this. Okay, and the equations that you will get here, the first equation is 7V1 minus V2 minus 4V3. So this is by simplifying the R1A. Let us consider by simplifying equation number 1, you will get the equation it as a 1A, and then by simplifying the second equation, then the second equation that you will get minus V1 plus 7V2 minus 2V3. Okay, so here which is equal to 0, and here it is which is equal to let me see, here it is 16. Okay, then here it is, let us consider here it is equation number 1A and here it is equation number 2A, right? And when coming to the third equation, here you will get 4V1 plus 2V2 and minus 7V3 which is equal to minus 36. Let us consider here this is 3A. Then if you write these equations in the matrix form, okay, then first the coefficients of V1 is, here it is 7 and V2 is minus 1 and V3 is minus 4. And similarly the coefficient of the V1, V2, V3 in the second equation is, here it is minus 1, 7 and minus 2. And in the third equation 4, 2 and minus 7. So this is equation on, okay, the coefficients, and then here you will get V1 and V2 and V3. Okay, then this equation is 16, 0 and minus 36. So if you make it this one, let us consider this is A and this is V and this is B. Then here A V is equal to B. Then from this, if you want to b, then send a at that side, then v is equal to a inverse into b. Okay, so if you find here a inverse into b, okay, a inverse into b, then here, then the finally the v equation which is equal, then because now you know a, then by using calculus you can find a inverse and b. So a inverse into b, then you will get the v matrix. So here v matrix that you will get here, it is a single column matrix, and then matrix values are 10 and 4.933, and another value is 12.26, 12.267. So here, which means here v1 is equal to 10 volts, and v2 is equal to here 4.933 volts, and here v3 is equal to 12.267 volts. So this is how we can find the values of v1, v2, v3 by using the nodal analysis. So I hope I have covered the various types of the electrical circuits, and for those circuits and how to apply the nodal analysis. Okay, so because first I have started with single node, and then after that 2 nodes and 3 nodes also that we have considered, and also I have considered a circuit which is having the dependent sources. Okay, so in that way also how to apply, and again another case also that I have considered, that when we will go for the super node analysis, right? So because when there is a voltage source in between the two nodes, okay, either it may be dependent or independent source, so in that case we will go for the super node analysis, right? So thank you.
Like, share and subscribe. Hit the bell icon for more updates.